This floating stack of magnets isn't just a fun desk toy. It actually models the Earth's atmosphere. Let me show you how. Earth's atmosphere is a thin layer of gases that surround our planet held closely by gravity. Without it, life as we know it wouldn't exist. It's made mostly of nitrogen and oxygen, with the rest a mix of argon, carbon dioxide, and tiny traces of other gases. There are 5 main layers that make up our atmosphere, and those are the troposphere. This is the layer closest to the Earth's surface. It extends up to around 8 to 15 kilometers depending on where you are, and this is where almost all of our weather happens. Then next there is the stratosphere. This extends from the top of the troposphere up to about 50 kilometers. This layer contains the ozone layer, which protects us from harmful ultraviolet rays. Next is the mesosphere. From about 50 to 85 kilometers up, most meteors finish burning up here as they enter the atmosphere. Then there is the thermosphere. It starts at 85 kilometers up to between 500 to 1000 kilometers. This is where northern lights and southern lights happen. I actually made a video where I took some photos of the southern lights. It was pretty cool. The last layer is the exosphere. This doesn't have a definite end. Most scientists believe it to gradually fade into space around 10,000 kilometers up. But what is also interesting is that the atmosphere doesn't even really end there. Some scientists have discovered that our atmosphere extends even beyond the moon to about 630,000 kilometers. But that is beside the point. And by the way, a huge thank you to AMF Magnetics for sponsoring this video. They sent me the magnets I'm using today to build this awesome atmospheric model. If you wanted to try this experiment yourself and make this cool desk toy, then there is a link in the description for their website, and you can use code SCOOP10 to get yourself 10% off any magnet you want. They have it all, from tiny magnets to giant monster magnets in all shapes and sizes. I encourage you to check them out. So thanks again to AMF Magnetics for sponsoring this video. So even though the atmosphere extends so far up, the majority of its mass is concentrated near the surface. In fact, about 75% of the atmosphere's mass is within the first 11 kilometers, and around 99% of the total mass of the atmosphere is packed into the first 30 kilometers. This concentration explains why air pressure and density drop so quickly as you climb higher. It's the reason your ears pop on a plane or when you drive up a mountain. Okay, so now back to our magnets. If you look closely, the gaps between the magnets show something interesting. The bottom magnet has to hold up the weight of all the magnets above it, meaning the gap is small, so it's compressed. But at the top, there's hardly any weight to hold, so it's not as compressed, making the gap bigger. In Earth's atmosphere, the force pushing back against gravity isn't magnetism, it's air pressure, but the effect is still the same. The higher you go, the less air there is above you, which means there's not as much weight pushing down, so the pressure drops. And a fun fact, if you were to climb to the summit of Mount Kilimanjaro, you'd be about 5.8 kilometers above sea level, but you would also be above half of Earth's entire atmosphere. That means the air pressure is only half of what it is at sea level up there. So this simple stack of magnets isn't a perfect model of the atmosphere, but it works well to understand it better. If you want more magnet videos, then check out this one here, where I explain why most things are secretly magnetic. And again, a huge thanks to AMF Magnetics for sponsoring this video. But if you did enjoy it, then please give it a big thumbs up, and don't forget to subscribe to see future videos like this.